solved grade 12 mathematics Ethiopian University entrance examination in English part 10, prepared and presented to you by Omar Adam Omar. As you remember, in our previous parts of video, we have solved a number of questions that are related to sequence and the series. Today, we begin a new chapter, new unit, which deals with calculus. The concept of calculus, you are not actually familiar in your previous classes. You are not familiar with the concept of calculus, and therefore we will see some of the concepts of calculus. Now, before we go any further, let me introduce you to this new mathematics known as calculus. Calculus divided into two parts. There are two types of calculus. One is differential and the other is integral calculus. Differential calculus, sometimes known as the derivation or derivatives. Now let us see the derivatives. Here, before we define the derivatives, what derivative is, let us see what should we have to understand prior to defining the derivatives. Under derivative, to understand derivative, we need to know the rate of changes, average rate of changes, and the instantaneous rate of changes. Now let us begin with rate of change. What is the rate of change? As you can see here, a rate of change is a rate that describes how one quantity changes in relation to another quantity. This means the change in an independent variables, if it causes change in dependent variables, then the ratio is said to be rate of change. Now, as you can see here, again, the units of rate of change is the unit of output per the unit of input unit. And another thing is average rate of change. Here, what is the average rate of change? Let us see. Average rate of change. The average, particularly we are interested in this section, we are interested the average rate of change of a function. And let us see, first let us see the definition itself. The average rate of change describes how much a function changes on average per unit over a given interval. It is a measure of the slope of a straight line connecting two points on the graph of the function within that interval. Here is how to calculate the average rate of change of a function. Suppose there is a function which is defined over this closed interval a up to b. Then the average rate of change is nothing but it is simply f of b, which is change in y with respect to this interval, over change in the value of b minus again a. What does this mean? When we are dealing with the function, what we mean by ARC is equal to f of b minus f of a over b minus a. Let me demonstrate using the graph of a function. Here I have already a graph of a function here, graph of a certain function. Let us see together, please. Okay, now consider this one. Let us consider the graph of y is equal to f of x. This blue curve is the graph of y is equal to f of x. Suppose this blue curve is the graph of y is equal to f of x. And also the red line is a straight line that intersects these blue curves, which is the graph of f of x, into 2 points. The first point is at x0 or x0 f of x0, and the second point is at x f of x. Let us investigate what the rate of change means. You know that here the point at this vertex is the intersection of this line and this line, the baseline and the altitude of a right angle triangle, which is denoted by x f of x0. The distance from this point to this point is change in y, which is equal to y minus y0, where y is equal to f of x and the y0 is equal to f of x0. And also the distance from this point x0 f of x0 to x f of x0 is given by change in x. Since f of x0 here is equal for the 2 pointers, since f of x0 remain on the horizontal line the same, then it becomes the difference, the change is 0, and therefore we only observe change in x. Change in x is also equal to the final x minus the initial x, which is x0, x minus x0. Now, this line, this red line that intersects the graph of this function, which means the blue curve, is known as the secant line. Any line that intersects the graph of a function at 2 points is said to be a secant line. We know how to find the slope of a secant line, or the slope of any straight line. Actually, the slope of any straight line is equal to the rise over the run, which means change in y over change in x, and this change in y over change in x will give us the slope of this line. Here, let us consider this one. The slope of this secant line, it becomes like this. I don't know if it is visible for you. Now, slope of this secant line, which means the red line, is given by change in y over change in x. But change in y is y minus y0. Our y is simply equal to the function f of x, and y0 is equal to f of x0. The difference f of x minus f of x0 over x minus x0 gives us the slope of this secant line. It is this slope that we say is the average rate of change of a function. We call this slope, the slope of a secant line, the average rate of change. Average rate of change. That is how we define the average rate of change. Another rate of change is also here. First, let me put this one somewhere here. Let us put somewhere here, and for later use, let me put this one. Now, another rate of change is known as the instantaneous rate of change. The instantaneous rate of change. As you can see here, this is the definition of the instantaneous rate of change. The instantaneous rate of change is nothing but it is simply a change at a certain period of time. According to this definition, the instantaneous rate of change refers to the rate at a specific instant, and it is equivalent to the change in the derivative value at that particular point. In other words, It represents how quickly a function is changing at a single moment in time. Now, let us explore this concept further again. Suppose this is a graph of the previous function. Suppose this is a graph of the previous function, and then the graph of the previous function, but instead let me use that one. That is more better than this one, and it is better to use this one, this graph. It can demonstrate each and every points on the graph. Therefore, it is better to use this one. Here, as you can see, let me put it somewhere here. If we pull down this red straight line, if we pull down, our x approaches x0. Our x simply goes to x0, while our f of x goes to f of x0. And then here, instead of this line becomes a tangent line which touch the curve at a single point, at the point x0 or x0, f of x0. In that case, the second line is changed into the tangent line. If we pull this one down, slowly down, I wish I can demonstrate using some movable line, but my technology cannot bear that one, and therefore let us see. Suppose we pull this thing down. Let me take here from somewhere here. Let us take from somewhere here. Okay, let us take this line. Now this red line, if we pull down, then this line will look like this one. Here, let us call this line B a second line. This line be a second line. I am sorry, something is disturbing here. Okay, here we call this line a second line. If we pull this red line downward, then it becomes like this one. Let me enlarge it a little bit. Let us enlarge it a little bit and put it like this one. Now, this red line becomes this tangent line. This is a tangent line we touch at this point. In that case, here, the slope of this red line, which is known as the second line, will be like this. Here, it is given as f of x. We say previously f of x minus f of x0. Here, the slope of that second line. Sorry for the delay actually. The slope of that second line was this one. It is f of x minus f of x0 over x minus x0. Now let us put this x minus x, the difference, change in x, as h. Suppose x minus x0 is equal to h. Then if we solve for x, our x is equal to x0 plus h. It becomes like that one. Then replace this x by x0 plus h. Here we have minus into f of x0. Then this change becomes h. As this x approaches, as we pull down, the red straight line downward to this black straight line, our this x approaches this x0. In that case, as x approaches x0, h approaches 0. H goes to 0. X goes to x0 means h goes to 0. And therefore, now the slope becomes like this one. The previous slope, this one and this one are the same. But as h goes to 0, as this h approaches 0, which means as this line, red line, after pulling this one and it becomes this black one, touch only at a single point, then this slope, the slope of the second line, will be changed into what we call the slope of the tangent line as h approaches 0. This must be, if this is omitted, then this is simply the slope of the average rate of change. In that case, we say this is the slope of the tangent line, the black one. It is the slope of this black one. And if f of x0 plus h minus f of x0 over h, as h approaches 0 exists, then this ratio as h approaches 0 is equal to the derivative of the function at x0. That is the definition of derivative. And moreover, we say it is the instantaneous rate of change. The instantaneous rate of change is equal to the derivative of the function at a point, and moreover, it is equal to the slope of the tangent line. That is the whole concept of the definition of derivatives. Now, having these concepts in mind, let us see some of the examples that might appear under this section. Let us see. Question number 1, it says, what is the average rate of change of f of x is equal to the square root of x cubed plus 1 over the interval 1 less than or equal to x less than or equal to 2. That is what the question says. Here there are multiple choices. Here, A up to D. Let us see how to find the average rate of change. We are asked to determine the average rate of change of this function. Then here, by definition, we say the average rate of change of a function over a certain interval from A up to B is equal to f of b minus f of a over b minus a. That was what we have said. Now, since this function is defined over this interval, then the average rate of change is simply equal to the second line, which is crossing at 2 points of the graph of f of x is equal to the square root of x cubed plus 1. That's it. F of 2 minus f of 1 over 2 minus 1. But since our f of x is this expression, then f of 2 means the square root of 2 cubed plus 1 minus f of 1 means the square root of 1 cubed plus 1 over 2 minus 1 means it is 1. And therefore, 2 cubed plus 9 plus 1, since 2 cubed is 8, 8 plus 1 gives us 9 under radical, minus 1 cubed is 1, 1 plus 1 is 2, and therefore the square root of 2 here. 9 is a perfect square, and therefore take 3 out of it. 3 minus radical 2 is the average rate of change. But let us check whether this number, this irrational number actually exists in our choice. Here we have 3 minus radical 2. But here we have radical 2 minus 3, which is different. And here we have 7 over radical 2 plus 3, We will check it later on whether it is equal to this number or not. Here we have 3 plus radical 2, but we have 3. Our answer is 3 minus radical 2. 3 minus radical 2. And another one, this is unequal to this one, and also this one is not equal to this one. And the probability of getting the correct answer is actually 50%. Either it is D or B. Let us check. First, we need to rationalize this one as follows. Rationalize this one. Rationalize this one means, here, let me show you in very simple shortcut way. Just square this one first. Square 3. When you square 3, it becomes 9. Minus square this one. Square radical 2. It becomes 2. Just put it over and then write these two numbers. Write these two numbers like this one. Plus 2. And then instead of writing this minus, put plus in between. That is rationalizing the numerator. That is rationalizing the numerator, which is going to be 7 over 3 plus radical 2. 3 plus radical 2. Now, let us see how I already solved this one. In what way? Here, 3 minus radical 2. To rationalize this numerator, because this number can be written as 3 minus radical 2 over 1, we multiply by rationalizing factor 3 plus radical 2 over 3 plus radical 2. This thing, if this number is divided by this one, it becomes 1. 1 is identity in the set of real number, multiplicative identity. Therefore, it doesn't affect the whole number, this number. And therefore, multiply 3 plus radical 2 by 3 minus radical 2. That's the difference of two squares. If we multiply, just multiply 3 by 3 and then radical 2 by radical 2. But things will be different if here is this one is plus and this one is also plus. Only 3 multiplied by 3 and radical 2 multiplied by radical 2 if one of the number is minus and the other is plus. And then it becomes 9 minus 2, and as I said, this number can be written as over 1, and therefore 1 times this number also 3 plus radical 2. The result is 7 over 3 plus radical 2, which is this one. Here we have 3 plus radical 2. Since addition is commutative, we can interchange these numbers. We can interchange. A plus B is always equal to B plus A in the set of real numbers, and therefore B is the right answer. B is the right answer. Let us see next question. Let us see next question. The next question says, which one of the following is equal to the instantaneous rate of change of the function f of x is equal to the square root of x plus 2 at x is equal to 2? We define the instantaneous rate of change is equal to the derivative of the function. The derivative of a function. Anyway, let us use the formal formula. Instantaneous rate of change, as we have already defined, is equal to f of x plus h minus f of x over h as h goes to 0. Replace x0 by simply x. Here, at x is equal to 2, the instantaneous rate of change becomes f of 2 plus h minus f of 2 over h as h goes to 0. Then, since our f of x is equal to the square root of x plus 2, then f of 2 plus h becomes the square root of 2 plus h plus 2. Replace 2 plus h, replace x by 2 plus h, and then we have previously 2 here. Then add this two expression together. And the minus f of 2 means it is the square root of 2 plus 2 over again h, as h goes to 0 or as h approaches 0. If you omit this one, this cannot be solved, and also it cannot be equal to the instantaneous rate of change, because the instantaneous rate of change is equal to the slope of the tangent line, which is again the derivative of the function at the point of tangency, and therefore we have to take h to 0. H approaches 0 always. And then now under the square root we have 2 plus h plus 2, which becomes 4 plus h, minus again the sum of this one is here, as you can see, is 4. But if we substitute, as h goes to 0, if we make h 0 here, as you can see, h is 0, 0, 0 plus 4, radical 4 minus 4 is 0. Again, h is 0, 0 over 0. In that case, there is no such number in mathematics, which is called 0 over 0, or any number over 0. No number. And therefore, what we have to do is, again, we have to rationalize the numerator in order to cancel h. What you have to do is immediately square this one. If we square radical 4 plus h, we will get 4 plus h. And also, if we square radical 4, we will get minus 4 over, put this number here, we have originally h, and then in bracket the number which is actually opposite in sign to this one, the radicals, that is radical, suppose this is radical, 4 plus h, instead of minus, replace this minus by plus, over radical, now this thing over here is 4. Then this 4 minus 4 is equal to 0. We have h as a numerator, and also we have h here, h cancel h. Then what we will have is 1 over this expression. Let us see here. Here radical 4 is simply 2. Radical 4 is 2. Then radical 4 plus h minus 2 out of the radical over h multiplied by the rationalizing factor. Our rationalizing factor in this case is 4 plus h under radical plus 2 out of radical, and also 4 plus h under radical plus 2 out of h, as h goes to 0. When we multiply these two, then the result will be 4 plus h minus 4 over, when we multiply these two, it becomes h times the square root of 4 plus h plus 2 outside of the radical. And then we have 4 minus 4, which is 0. Then we have h as a numerator, and also h times this expression as a denominator. Cancel this h. We have 1 over radical 4 plus h plus 2 as h approaches 0. Now we can make h 0 right now. We can put h is equal to 0. We can simply put h 0. In that case, we have 1 over 4 plus 0 is 4 under the square root or under radical, plus outside of the radical we have 2. Then 4 is a perfect square, it becomes 2 plus 2. Therefore our answer is 1 over 4. It is exactly 1 over 4. Which one is it? C. If you say C, then you get a point. Let us see the next question. This question is, it looks like the application of derivatives. It looks like application of derivatives. It says the biomass of bacteria's culture in milligrams as a function of time in minutes is given by f of t is equal to 12t cubed plus 35. What is the instantaneous rate of growth of the culture when t is equal to 2 minutes? We have the bacterian culture, and here the bacteria multiplies every seconds and every minutes, and then the growth, its growth is given by this function. The question says, what is the instantaneous rate of growth when t is equal to 2 minutes? That is what the question says. What we have to do is the following. Simply derive this one to find the instantaneous. We say the instantaneous rate of change is the derivative of the function at a point, and therefore if we derive f of t, then we will get here multiply 3 by 12, which is 36, then subtract from 3 1, we have t square, and the derivative of the constant number is 0. Always the derivative of any constant is 0, and therefore what is f prime of t? F prime of t in that case is, here we have 36 as you can see here, 36 times 2 square. Here is 2 square, replace t by 2 square, and therefore 36 times 4 gives us 144 bacteria will be there after 2 minutes. If the growth is at this rate, is given by this function, then after 2, when our time is 2 minutes, then the growth is about 144. Not about, actually, it is exactly 144. Therefore, it is this value that we call the instantaneous rate of change. Since the instantaneous rate of change, as we have already defined, is equal to the slope of the tangent line, which is given by the derivative of the function at the point of tangency, and therefore the answer is A. Our answer is A. That is question number 3. Let us see one final question. Question number 4. It says, let f of x is equal to 3x squared plus x. Then which of the following is equal to f of 2 plus h minus f of 2 over h as h closer to 0? That is what the question says. If it was me who is dealing with this particular question, what I have to do is nothing, but I have to derive this one, because always f of 2, we say previously, f of x0 plus h minus f of x0 over h as h approaches 0 is equal to the derivative of the function. Therefore, f of 2 plus h minus f of 2 over h as h approaches 0 must be equal to f prime of 2. It must be equal to f prime of 2. F prime of 2. And therefore, simply derive this function with respect to x. Derive this function. F prime of x, we say with respect to x, it becomes f prime of x. Okay, f prime of x, and then multiply this 2 by this one. You have already learned the derivative of the power function, and therefore there is actually no problem in dealing with the derivative of such polynomial expressions. Here the derivative of x is 1, and then put f prime of 2. F prime of 2. When our x is replaced by 2, then the result is equal to here 6 times 2 here, 6 times 2 plus 1 plus 1. 6 times 2 gives us 12, and therefore the result is 1 3, which is 13. That is the limit of this expression. The limit of this expression as h approaches 0. It is f of 2 plus h minus f of 2 over h as h approaches 0 is exactly equal to 13, given that the function f of x is equal to 3x squared plus x. Now let us use the traditional method. Before calculus was invented, people solve such question like this. Here f of 2 plus h minus f of 2 over h is equal to our h, put this one here, our h is 3x squared plus 2, therefore f of 2 plus h is equal to 3 into 2 plus h square, the whole square plus again 2 plus h, replace this x by 2 plus h minus the whole thing, put it in bracket. F of 2 is also equal to 3 times 2 square, which is 4 times 3, which is 12 plus also here we have 2, it is 14, 1 4, and therefore 3 times 2 square plus 2, which becomes like this one, 3 into square this 2 plus h, the whole square means it is 4 plus, first square this one, square this 2, it becomes 4, then multiply these numbers 2 and h, and then again multiply by 2, which becomes 4h, and then plus again square h square. That's it. 2 plus h the whole square means it is equal to 4 plus 4h plus h square. We have proved this one in grade 9, in grade 10, and in your previous lesson you have seen such kind of mathematical expressions or mathematical calculation. I would rather say that. Plus here we have this one 2 plus h minus we say this one 3 times 4 is 12, 12 and 2 it is 14 here, over h as h goes to 0. Don't forget to put as h goes to 0, and then here multiply 3 by 4, it becomes 12, 3 by 4 12h, 3 by h square 3h square, plus here we have 2 plus h minus 14. Then let us add similar terms or subtract similar terms together if there exists. Here as you can see 14 and minus 14 are numbers, pure number, therefore we call them similar terms, then they cancel each other. What is left here? 13 h plus 3h square over h. Then we can cancel this one, common out h from this expression. Here when h is common out, when one h is pulled out of distribution, this multiplicative distribution over addition, then it becomes h into 13 plus 3h. Now we can cancel h by h, and then the result is 13 plus 3h. Now as h approaches 0, then that limit, this expression, this ratio approaches 13. It approaches 13. As h goes to 0, we have 13 plus 3h approaches 13, and therefore this expression becomes 13, given that f of x is equal to 3x squared plus x. That is the last question. Any question, or anybody who will try to prepare an exam from this part alone, will never prepare questions that are more difficult than this. I swear. I know everyone, particularly in our country, Ethiopia. And that is all for today. Next time, we will see the detailed and the more complex questions that are related to calculus, derivatives, and also integral calculus. Then until then, please, if you like the way I present this lesson, just click the like button. And moreover, if you like, just share it and tell me the comment. I need your comment. Your comment has greater value for me. Now, this is it. See you, please. We will see next time. Bye bye.